Okay, I'm going to make this a really short introduction because what I understand when I start talking about equivalence and start talking about writing equivalent equations, that there's this almost moment of horror where most people don't understand what's going on, okay? And it takes a little bit to see this. And you can look in a textbook full of algebra and full of equations and you think, oh, how do these guys make up these questions? And it's kind of, I don't know whether it's a secret or not, but I think they start off with really simple equivalent equations and then pop in things around. And I'm starting to read them as the clues to help me unwind something and get back to a really simple statement like x equals 4. And if I want to create a more difficult equation, I could say if I started with x equals 4, I could multiply both sides by 3. So my new equivalent equation would be 3x equals 12. Okay? The value of x, if I look back inside and solve that by inspection, the value of x hasn't changed. It's still 4. So if I want to create something a little bit more difficult here, I've went from x equals 4 to 3x equals 12. Why don't I add 5 to both sides of the equation? So on the left-hand side, my equation was starting to look like 3x plus 5 equals, it was 12, but I've added 5 to both sides on both sides. So on the right-hand side, I've got to just tidy this up. I've got 12 plus 5. Instead of writing that, I'm going to write equals 17. I started off with something really simple, and in 3 steps, I've just made it look different. But underneath all that, if I still solve by inspection, the value of x hasn't changed. It's still the same. And once you understand that and you start looking at all the questions in the textbook, you start to see the tricks and the games that are being played in the setup of these questions. And then they become easy. You start to get a sense of the puzzle that's been created for you. And then you can either, and most times what we're asked to do is unwind all that and get it back to its most simplest core statement, such as x equals 4. Okay, so I'm going to show those things to you on the board and just ask that you persist and through this discover how the game is played. All right? Now in this video we talked about equivalent equations, and this is something tricky. Students find this tricky. They're not sure what to do, and often it's just writing out a new equation after manipulating it some way. So let's just down here, we'll try an easy one to start with, and you'll notice there's square brackets there and they're saying let's add 1 to this. All right, so that's what they're asking you to do. So it's just a number, and so we needed to add it to the left hand side and then the right hand side. So we've already got this plus x here. We can't do much with that. We've got the equal sign there, and our focus has to be here on the 5, and we're going to change that from a 5 to a 6. It's told us in the square brackets over there to add 1, so that's 6 plus x on the left hand side. That's our new equation, and over here we're going from 11 to 12. Now it's really important, if you focus in on here and start thinking about what the value of x is, in this situation it hasn't changed. It's still worth 6. And in our new equation, the value of x is still 6. So the value of the pronumeral does not change when we apply these manipulations to the equation. So that's what we mean by equivalent. Okay, they look different, but essentially they're the same. So let's try a few more. Let's try this. We've got 3x is equal to 2, and we're told to multiply this by 2. So how's that going to look in our new equation? Well, we're doubling everything here. Timesing by 2 is same thing as doubling. So that turns into 6x, and that's equal to 4. Okay, so it's a little bit hard here to see what the value of x is, but we can do it. Let's look at this first equation here, and I might use a bit of room down here and rewrite it again. Sorry, 3x equals 2. Now there's a little trick here. 3 over 1 times 2 over 3 is equal to 2, and they'll cancel. So the value here, and I'm going to rub that out because here's the value of x. X is equal to 2 over 3. Okay, so even in the second equation, if you're not sure what that looks like, let's do this. 6 over 1 times 2 over 3. And let's cancel that down. 3 goes into 3 once and 3 goes in here twice. So this turns into 2 times 2, which is equal to 4. So it's the same value. That hasn't changed, and that is the key thing that you need to remember here. So let's try a new equation. We've got 4x plus 2, and we're told that that's equal to 10. And our moves here, what they're asking us to do is subtract 2 from both sides. So what does that look like? This stays the same. This 4 times x stays the same. Plus 2 subtract 2, well, we could write plus 0, and that would be okay. Or we could just forget about knowing that it is 0. No one in mathematics writes plus 0, so maybe we could set it up this way. We could write 4x equals, now we've got on the right hand side, we've got 10 and we need to subtract 2. Okay, so it's really important, again, just to reinforce that idea, and look here for the value of x. Up here in a solving by inspection, x is equal to 2. And down in the second equation, equivalent equation here, the value of x is still 2, so it hasn't changed. And I just want you to understand that, and that's all we're doing is actually rewriting a new equation. It looks different, but the fundamental thing is that the value of the pronumeral hasn't changed while we've applied these different operations. If we start here with the value of x is equal to 5, all right, and our instructions are, let's add 4, and what we've got to do to one side we do to the other side. That's a must. So what will that look like? X plus 4 on the left hand side, and if we're adding 4, we've got 5 on the right hand side, we add another 4 and that's 9. Okay, so perhaps then we're told to multiply everything by 3. Okay, so I'm just making this stuff up here. So we're told to add 4 and we're told to multiply by 3. I think that's what I said. So now we're going to do that, and my tip here is that everything needs to be multiplied by 3, and it's probably easiest to do 9 times 3 is 27 on the right hand side first, and then come over here. Everything here on the left hand side needs to be multiplied by 3, so that's 3 times x, 3x, plus 3 times 4 is 12. Okay, and that's what we need. Has the value of x changed? Let's check in here. So what have we got? We said it was 5 originally, and it's still 5 here. So I just want to check that x is actually equal to 5. So on the left hand side we've got 3 times 5, which is 15, plus another 12, and that's equal to 27 on the right hand side. So that's true. The value of the pronumeral hasn't changed as we've applied these things. So let's play this game again. I'll just change the color of my pen here, and we'll start off the same way. We'll start with x is equal to 5. And while we're doing this, just think about how these questions are set up in your textbook. Okay, it's not magic. Whoever's writing these questions is starting off something basic like this. They're saying x is equal to 5, and then they're building it up and making it more complicated. So I'm looking here and I'm thinking, well, what's the first move here? And I think we might need to multiply both sides by 3. So this becomes 3x plus, 3x equals 15. And now this is going to make sense because my next move here will be to add 2 to both sides. And that's where that plus 2 has come from, and that's how 15 has changed to 17. So that looks pretty good to me. So now I know that I've created something that looks more complicated, but again, we can still stop and check. If x is equal to 5, let's do this. 3 times 5 is 15, plus another 2, and that's equal to 17. So the value of x is still the same. Now, this is one of the questions in the textbook, and it's worth doing this, and I want to show you perhaps a different way to do things. And it's got a couple of clues in here, and it's like unlocking a puzzle. We're going to use equivalent fractions, and we're going to go from the top one to down the bottom here. This plus 1 equals 41. Okay, so how do we get there? So there's some clues here. First clue here, what have we done? We've subtracted 2. I think we've subtracted 2 from both sides. Okay, and that kind of matches up here. How did we go from 14 to 12? We subtracted 2 from both sides. And I think the next move needs to be, we need to divide both sides by 3. Okay, because we've got 3 times x here, and what's that going to look like? That's going to look like x is equal to, because 3 goes into 3 once. It may be worth pointing that out to you. 3 divided by 3 is 1. So we don't write 1x there. We can, but we generally don't because we're lazy. We'll just write the pronumeral out there. So that's an x. And we've got to think about 12 divided by 3, and 3 goes in there 4 times. That's our new equivalent equation. And from here, we can literally turn it into anything else. And what we're going to do is turn it into 10x plus 1. So let's look at the clues. This number's quite large, and we're multiplied by 10. So I think our first move here will be timesing by 10. And so that's going to look like 10x is equal to 40. Okay, the value of x hasn't changed here. And we'll check that out in a second, because I just keep saying this, and I'll keep saying it over and over again until you get what I'm saying. So hang on a minute. Let's look down here at the bottom one. We've got add 1. So I reckon our next move will be to add 1 to both sides. So this is going to look like 10x plus 1 on the left hand side. That's was 40, and now it's 41. So there's our final equation. Looks like nothing like what it was originally. So let's go back and just double check our starting equation. So 3 times something, 3 times 4 is 12 plus 2 is 14. So x is equal to 4 here. And x is still equal to 4 there. And what about here? We've got 10 times 4. So x is equal to 4 here. And I'll just reinforce that whole message to you one more time before we finish up, that even though they look very different and we can move from one equation to the next, the actual value of the pronumeral while we're doing all these steps has not changed. Okay, thank you.